Coming up this week on Let's Make It, we make a VU meter with an Arduino right after this. Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello and welcome to episode 23 of Let's Make It. And this week I'm kind of going solo. I heard from Bob today, and he has had some kind of emergency or something he had to run out for, and he couldn't make it tonight. However, this week was VU meters, and I was kind of my week, so we should be okay. Although I hope everything's good with him. I have not heard from him since he said he had an emergency he had to go run for. So hopefully it was nothing serious. So, before we get too far, I want to remind you, and they're just going to be doing this for the next 5 episodes, up through episode, what would that be, 28, to tell you that the YouTube channel for Let's Make It is being moved to a single channel for TechZen TV. So, if you've been watching the shows on our YouTube channel and you subscribe to them, you need to go, before you forget, to youtube.com/TechZenTV and subscribe over there. The show you're watching right now should be there as well. We're for the next 5 weeks, we're putting them in both locations, but after the 5 weeks are up, it's only going to be in the new location. So if you're watching us right now, before you go too much farther in this video, just go to youtube.com/TechZenTV and hit the subscribe button, and then you can find this episode and restart it since we're so close in the beginning. And we'll keep reminding you of that as it goes along. Now, there is a playlist over there on that channel. So if you're only watching the Let's Make It show on TechZen TV, you can just subscribe to that particular playlist, and you don't have to watch any of the other shows. However, you may want to take a look at some of the other shows. You may be interested in some of them as well. So I will remind you that again before we go. So this week, we really only have one segment, and it's something that is kind of neat, although what you're going to find is it doesn't really look like it's functioning exactly right. And I'll explain why that is. And it is functioning right, and you'll be able to tell by watching it. So this week we're going to create a VU meter. And when I first go to this, we're going to show it to you. Just look at the thing on the left. The other two I'm going to talk about here in a little bit coming after that. So let's go take a look at it. And before we walk through the code, you see on the left, the thing that's bouncing up and down, that is the VU meter. And if I get really quiet, you see there's still some noise on the bottom. That's because right now I have it plugged into our in-ear monitor. So that's very noisy. It has a lot of noise on the bottom of it, and I had to turn it up fairly loud to have it pick it up. So it has a noise floor on it. Now, this particular VU meter has a couple modes to it, and there's a button here. I'm going to go through all this stuff in a little bit, but this button turns it into peak mode and not peak mode. Now, the other thing you're going to notice, and I don't know how it's going to sound to you versus how it's looking, our audio is a little bit delayed because it's video processed. So the exact peak of my voice isn't going to be exactly with it. At least it doesn't look like it to me. It may look like it on the final recording that it's normal. So I can't really tell, but if you're not getting my voice in the peak at exactly the same time, that is what the problem is there's some video delay some audio delay we've introduced to try to get the audio and the video to match, but because I'm using an internal camera, it may not be matching. So, but right now it's in non-peak mode, and there's a button here. I'm going to put it back into peak mode again. So that's peak mode, and you see that one LED that stays up there for 2 seconds, and then it resets itself back to the next level. That's the peak mode option. And you just turn it off and on by hitting the button, just toggles it back and forth. Now, there's a lot on this board, and actually what I've done is I've actually have a schematic I'm going to show you, and a general layout of the breadboard as well. That's not exactly how I have it right now, but it's pretty close. The parts are the same and everything. It's just they're not. I moved some things around a little bit. So let's go take a look at that stuff. Let me get it up here on my screen. All right, so this is going to be the breadboard layout. And basically what I have is I have 5 volts in ground heading over to the bars, and then you see I've actually taken the bars across to the other side. And this is how the one you're looking at is. So one of the things that's different is this was showing 10 LEDs. I used a 10 LED bar just because it looks more like a meter. And then you have your resistors right here. And then each of these LEDs goes to between pin 3 and 12 on the Arduino. So this is how we're lighting it up. And there's a button right here. It's kind of hidden by these LEDs. And we'll go into the schematic here and you'll see this. And the button basically goes to pin 2 on the Arduino, which is how we're toggling on and off the peak mode. And we'll walk through the code and we'll show you the peak mode. Now, the one thing that's different here compared to our other normal shows is we've actually added, I guess what they consider a B class amplifier, because the signal coming in from a microphone or the line that I'm using is very weak and it's very low for the Arduino and it won't pick it up. So what we have to do is we use an NPN transistor and we build a little amplifier that takes this signal coming in from the line and amplifies it so the Arduino can see it, which is also another part of the problem. The capacitor I should be using is a 100 nanofarad, and I don't have one that's exactly that size. So this one is just a little bit bigger, and that means I have to push it a little bit harder to get the signal to come in. So it's not as sensitive as it would be if it was the proper size. But you can play with different sizes, but the 100 NM is probably the best. So, and you see a couple resistors right here. So what we're doing with this resistor is we're making it so it works like a class B. So it's always holding a little bit of signal there. And the idea is audio has peaks and valleys, and this helps do the peaks and valleys. You could use a class A amplifier as well, which would only get you the peaks, the top part of the wave. But I think that the class B, which is typically what's used in most audio preamps, is a class B type amplifier, is probably the better solution. Now it does pick up a little bit more noise and maybe a little bit more sensitive in some ways, but it's probably the best one for this particular application. If I had to break a capacitor, it would probably work just fine. I played with different size capacitors going both directions, and when I went too small, it was way oversensitive. So this makes it less sensitive than what it should be. So that's probably the better way to go versus being too sensitive by putting a smaller capacitor in there. All right, so let's go take a look at the actual schematic. And you see the Arduino, and you see I have off of pins D3 through D12, the LEDs, and they're all going to the resistor, which goes to ground. And you see the button right here. I have a resistor going to ground, so it pulls that pin low. But when you push the button, it takes it high to 5 volts, and you see in the code that whenever D2 is pressed, I just change the mode from peak or not peak. And then over here is the transistor. This shows a microphone, and I played with the microphone. It worked okay, but this, I think the line input, we could actually hear me and see whenever I was talking, was a little bit more demonstrative of it. So I basically took out the mic and put a connector on to go to our headphone amplifier for our in-ears in the studio here. So what you have here is you have a resistor, and this is a 10K resistor right here, and it just basically putting a positive onto the capacitor, and the microphone goes, it puts voltage into the microphone as well, and goes to ground. And as you talk into the microphone, it takes it up and down, voltage up and down across the capacitor, which then goes into the transistor right here. And this here is a 100K, so this is really being pulled it's being pulled high, but very little. And it's basically going through the 10K and 100K. And then you have your 10K right here, which is making sure that when this thing opens up, it doesn't go 100% from +5 to ground. And So basically, when you have a positive signal come in, it's coming down and it's opening up this transistor, which opens up to ground, which takes and pulls A0 low. And then whenever it has a negative signal or no signal, it basically closes up the transistor, or doesn't completely close it up, because that's the whole reason for having this resistor here, is to keep it. This is what's considered a class B. This is what makes it a class B amplifier. So if this goes open and closed, the amount of voltage you're putting on A0 is going up and down based on the resistor you have here of 10K. So 10K is always keeping a little bit of positive, but the more you open it up, it's going more to ground. So A0 is picking up that change, and we look through the code, you'll be able to see how we're doing that. So it's not overly complicated. If you're not familiar with using a transistor for amplification, there's a couple good articles out there. If you just search for transistor class A or transistor class B, you'll be able to find these. It's like a little mini amplifier. It just takes this signal and strengthens it so that the Arduino can see it. If you just plug this mic directly into the Arduino, you would see something, but it'd be very little, and it wouldn't be able to be measured necessarily. In this case, we're actually able to measure it up to, I think I figured out it was like 900 and some was the top value I was getting. So that could be tweaked a little bit. This 10K resistor could be changed around a little bit to bring this back up. But the main reason for this 10K resistor is to not short out basically this transistor. Whenever you would bring positive into it, you would have no resistance in this circle, and it wouldn't be good. So that's what we put that in there for. All right, so let's go over to the actual Arduino code. Let's see, VU meter. Oops, too fast. And let's walk through the code. So the very first thing I do is I create an array of all the pins. So the bottom is pin 3, and that is the bottom LED. And it's pin 4, 5, 6, 7, 8, 9, 10, up to 12. So here's our array of 10 LEDs. Our switch is connected to our data pin 2. And our sound pin that we're going to read in the value from is A0. So we make it equal to 0. By default, we're going to show peak as false. And then we're going to set our peak value on our last peak, and I'll show you how we use last peak. This is something that's, you don't want the peak to always stay there. I mean, you could hold the peak there if you wanted to, but typically you don't want to be the peak that's recent. You don't want it to be stuck that whole time. So I'll show you how we use last peak for that. All right, so through our setup, all I'm doing is looping through all the pins, making them all output. This is just easier than putting in LED pins, or pins 2 through whatever, and just copying it. Just makes it a little cleaner by making a little loop. I set our switch pin, which is pin 2, to input. And actually, the serial begin was me debugging some stuff. This isn't normally here, so I'll take it out. It looks more like this normally. And so now we go into our loop, and I'm going to digitally read switch pin, which is determining if the button is pressed to change our mode. If the button was pressed, I'm going to reverse the mode we're currently in. So I just do that by saying it's not show peak. And since show peak is a Boolean, which you'll see right here, Boolean, it can only be true or false. So if it's true, it's going to say it's not equal to true, which means it's false. If it's false, it's going to say not equal to false, which means it's true. That's the nice thing about a Boolean. It can only be one or the other. I'm also going to reset our peak value back to 0, so I'm sure that the peak value, last one, is gone. And you see right here, I was printing out the button press. This was what my debug code was, and I need to get rid of that now. And I'm going to wait 200 milliseconds. And the main reason we wait 200 milliseconds at this point is button debounce. Now, basically what button debounce is, sometimes you press the button one time, and it actually registers as 2 or 3 times, just because the way the button bounces internally. It just happens so fast. So you do a little bit of a delay, and so the button doesn't pick up as being bounced. And I've still seen a 200 millisecond delay take a button debounce and pick it up, but it's very rare. So next thing we're going to do is we're going to read our value in on the analog read of sound pin. And what we're going to use is, we talked about this map command, I think it's like 2-3 weeks ago. And basically what it does is it takes this value and it maps it to a array or a range that has the top of 1023. So we know that and we're going to match it to 11. So we know that our value is between 0 and 1023, because that's the range that you can read in on the Arduino analog read. So we say, here's our value. Let's say we brought it in as 500, for example. And we want to say between 0 and 1023. So 500 is a little less than 50%. And what it's going to do is it's going to say, okay, I want to convert that to between 0 and 11. So let's say it's exactly 50%. We'd come over here and it'd be 5.5 would be the map value. Now it's going to round it up to 6. And then we're going to subtract 1 from it, which puts it back in the range of 0 to 10. So that's how we determine what the top LED is. It's just using this map value. It just takes two ranges of values and converts one to the other. Basically is what the map does. Or I should say it maps it from one to the other. That's probably why it's called map. So the next thing we're going to do is we're going to see how long ago it was that we got our peak. So if the current number of milliseconds is greater than the last time we got the peak value plus 2 seconds, then we want to say peak value is equal to 0. And the reason we do this is if we peak, we do not want it to stay there. Well, you might want it to stay there. If you do, you take this out. They basically would take this line right here out. But I don't really want the peak. I want it to look like a regular peak meter. And actually, I think 2 seconds is probably a little bit too long. It's probably close to be 1.5 seconds based on watching the meter. But basically, the highest LED will stay lit for up to 2 seconds. Now, if it keeps hitting that peak, it'll stay there, because every time you come down and this top LED is over, it's going to reset the last peak value. So, but if it drops down after 2 seconds, basically what's doing is saying peak value equals 0. Well, then the next thing it's going to say top LED is greater than peak value. Well, if it's any LED on, it's going to be greater than 0. So it's going to reset that peak value and reset the last time. So it's just our way of putting a timer on that peak. And then I'm going to come down and I'm going to write out each of the LEDs based on their current position. So I'm just looping through all the LEDs. So I'm saying the LED pin is whatever I set, which is 3, 4, 5, whatever it is, up to 12. And here, this is a conditional statement. So if, man, I feel bad burping. All right, this is a conditional statement. So what it says is if I, which is this loop, is less than or equal to the top LED, or it's show peak and I is equal to the peak value. So if either of these two conditions are true, this is going to be a true statement, which means this LED will turn on. So it's the case where I is greater than the top LED and it's not peaked, then it won't turn on. But if I is greater than the top LED, and here's the OR statement, and it's peaked, or it's peaked, and its I is equal to the peak value, then the LED should turn on. So basically, we're just saying this double condition statement right here is either true or false when it's evaluated, and that just tells digital write true or false, which means off or on. Now, I'm delaying it for 50 milliseconds. I could probably delay it a little bit less than that. I haven't really experimented a lot with this, but I was getting some flickering, and I was trying to take care of the flickering by putting a little bit of a delay in here. Although I'm not sure that actually solved the problem, the flickering. So that's it. That is how you can create a really simple VU meter with an Arduino. And I'll put this code up online so that you can download it. And the schematic I'll put up there as well. You can download that and build something for yourself. Now, again, I'll put the right value of the capacitor that should be out there versus the one that I'm using. I think the one I'm using is almost twice the size it should be, but the one that I had was less than half the size that it should have been, and I didn't have anything to kind of fit in the middle there. So that would definitely make it a little bit better. Now, the other thing that should probably be done is putting on the preamp or the amplifier we have in there, the potentiometer, so you can adjust some of the input. Because if you get a very heavy input, you might want to be able to back it down so you're not overdriving the amplifier that's in there. In my case, I'm definitely not overdriving it, so I didn't really worry about it. And as I said, I have it plugged into the amplifier that's right here that goes into our in-ears, and I just got the volume adjusted so that it's so it shows that I'm talking, basically. The problem with that is I had to get it loud enough that there's a noise floor, and the noise floor is definitely showing up in that meter. It's definitely sensitive in that area in the lower end of the noise floor. All right, so while we were over here and we were looking at this, you might have seen the other things that are making all kinds of flickering things on the right over here. And last week we mentioned, and I got these over here, that we have these boards now. So I decided to put some together to show you what they are. So these are basically shift register boards from our previous shows. Actually, I can tell you which one it is. Let's make it 17. It's right on the board. It tells you what show it was from. So I mentioned we're going to start putting these out there to sell. I did have one issue that I'm going to try to fix before I start producing these in any kind of mass. And that is that on this bottom side, we have these little plugs that go into the shield, and this chip is pretty close to the Arduino metal piece that's right here. And if you're not careful, it could short it out. So I'm going to try to move some things around to solve that. The way I solved it with these was a piece of electrical tape right on top of the piece of metal. It's right there, and it's fine. They fit together just fine. Just they do touch with the way the chip is located. And the only other thing, which I'm not sure I'm really going to fix, is the LEDs in the center of this one are not quite straight. When I designed the board, I told it I wanted to center those LEDs, and it said it did, and you can tell it's not centered, but they're turned opposite directions. So I assumed that meant that it was still centered, but it's not. You can't really tell it so much when you're looking at it. This is the one right here that's doing that. So I'm not sure I'm going to worry about it that much. This does use smaller LEDs, mainly because if I want to do the crisscross, the plus sign, and they're too close together for the bigger LEDs like are on this one. So that's why I decided to use the smaller LEDs just to get them all to fit onto this board. But you can see these are actually running the programs that we had in the show, with the exception of this particular one right here. It has a few additional things in it that I've added just to demonstrate the X. Well, the X or the plus, whatever you want to call it. You can put like an X if you want, like that. And as it goes around, you'll see it's a couple of things that I've done just to demonstrate the X. But for the most part, this is the code that Bob showed us in his show. Like right here, we're getting ready to start a couple of things that are new. We just did our flash. Well, I say that, and it's going to make a liar out of me. Oh, there we go. There's our flash. Okay, so there we go. That's some new stuff right there. And then it goes the other direction. Then it does a little bit bigger. Then it does a little weighty thingy, spinny thing. So yeah, a little paddle wave. So there's a couple things in there that I've added. But for the most part, this is the code that we actually used on that show, and is available out there at the link that Bob has out there for his program. So you can pretty much buy these boards. Now, they're not going to come assembled. They'll come with the parts, but they won't come assembled. So you're going to have to solder them. But it does take around about 15-20 minutes to solder. In fact, I'll probably do some short videos and putting some together just to show you how easy it is to put them together. It took me 15-20 minutes probably to put them both together. And that was even when I messed one of them up and had to clean it up a little bit. So, and that was me. That wasn't it. It worked fine after I did that. It just happens to be I didn't follow my own instructions, which happens from time to time. So that will be out there very, very soon. In fact, we're going to start doing some more of these shields. Bob and I have been talking about doing some more of the shields here, and I'm not sure what our next shield's going to be. I may make a shield based on today's show. I may just start doing them for every episode and start putting them out there. Of course, I will make sure the right part sizes are in the kit when they come, so that the right capacitor is involved and all that stuff as well. All right, so like I said, this week was going to be fairly quick because I only had one thing to talk about, and it was very simple, actually. Much simpler than what I thought it was going to be when I first started it, because I had never done anything like the VU meter in the Arduino. I wasn't sure how easy it's going to be to read that in. And actually, it turned out to be, after I first figured out that the signal coming in was too weak for it to get a good read value from it. It didn't take me long at all to figure out that. I just went out and did a Class B type amplifier with a transistor and tweaked it a little bit because I didn't have the right capacitor based on my calculations, but I'll include make sure the right ones are included and get that fixed up for you. All right, so we've asked you before, and I remember we asked this with Bob on the here one last week before about are we going in depth enough? Like tonight, I put in a transistor. Should I have gone deeper into how the transistor works? I mean, I told you it was an NPN, but do you know what a negative, positive, negative transistor does? Or do we need to go into that detailed level? And we don't mind doing that, but we don't want to do it if something that you don't want. So you really need to give us some feedback as to how deep you want us to go. We typically, if we use an acronym, we try to spell it out a little bit. That's why I said the negative, positive, negative, but most people don't know it. That's what it means. Most people just know it's an NPN and know how it works. The question is, do we need to explain a little bit more how it works? So I need to explain a little bit more about the Class B amplifier theory, that type of stuff. So, but we really, really need your feedback to tell us, where do we need to go and how deep we need to go. We got shows planned out for a long time. In fact, I will tell you approximately how many we have. Let's see, this is episode 23, and we have ideas up through 34 already for shows. It doesn't mean we can't throw other things in there. So we have enough for another 11 weeks, and that's just off the top of our heads. So we can keep on going and going and going. But if you have something you want us to talk about or go a certain direction, we want the show to be for you. So I know we've asked for it before, but if you could just send us a note at Let's Make It at tech-zen.tv, and I only just need your opinion. Do we need to go deeper? Do we go deep enough? And you don't really want to go that deep into electronics, in the actual electronics theory. You want to stick into the CPU, in the coding realm, or that's the kind of thing we need to know what direction you want to go. I will tell you a few of the things that are in this list. I don't know exactly in what order they're in here, but actually maybe I do. So we have LED arrays, which LCD thermostat, an infrared remote. We have a lie detector coming up, motor controllers, and another separate week with separate motors. Then we also have Android and the Arduino, tying them together. So having Android and the Arduino talk. A virtual USB keyboard, which is like using the Leonardo to simulate a keyboard back in. Let's do some things with that. We've actually had somebody ask about this one, time-lapse camera controller, a touch control panel, speech synthesizer. So what other types of things are you looking for? I actually have a couple of them that I'd like to add to this list. I recently had a power issue with a refrigerator and a freezer in the garage and did not know it until everything was ruined. So I do have something I want to make for that. That's a request of my wife. Why don't you make one of these for me? So that's why we'll have to do that. Actually, I'm going to add it to the list right here. So that'll go in that list somewhere too. I also wanted to do some CAN bus type, or the 2-wire bus type communication. I have a couple applications of that kind of stuff that I might need here soon. So we're going to look at that. Maybe as a possibility of having multiple Arduinos communicate over the 2-wire interface. And it's something we can talk about too. And that's I think CAN bus is the one that's the most popular. It's used on a lot of cars. So maybe we'll look at doing something like that. Let's see. I had a couple of things I was thinking about, but that's the kind of thing that we want to hear from you. Is like, what do you want to learn, or what do you want us to try to make? There are other shows like this that go through our whole project. I'm making something much bigger than what we're making, like this little tiny VU meter. It's a great way to learn how to use the Arduino to do that kind of stuff, but it doesn't really serve a practical purpose necessarily. It's more of a learning how to do it. Would you be interested in seeing us take on a project, like a big project? I mentioned before about building a robot, and I have all the parts to build the robot. It's one of those things where I haven't had the time to sit down and start working on it. But that would be something we do over a period of weeks. Is it the kind of thing you'd like to see us do? And do you have ideas of things you want us to make as well? So, we definitely would like your input. Where to go. Like I said, we got 11 weeks. So actually, I got now 13 weeks of content that we already know we want to do, but it doesn't mean we have to do it like right now. We can pop in other things in between there. So we got a ways to go, but we definitely would like some input from you on what you want us to do. All right. Well, before you forget, go change your subscription on YouTube, youtube.com/TechZenTV. If you have a project you'd like to show us, we'd love to see it. You can just put it out in a video, put it up on YouTube, send us a link to it, and we'll take a look. And if you want, willing to show it, let us know that too, and we'll stick it out there on our show as well. Show everybody what you're making. If you have any questions or comments, we definitely appreciate those. We've been getting a lot of those, and we love them. And you can just send email to let's make it at tech-zen.tv as well, and we'll get that. And that's probably the best thing you can do. If you're watching us on like iTunes, you go ahead and hit subscribe. While you're out there though and hitting subscribe, can you leave us a 5-star rating and some comments? We definitely need some help getting found out there. And the more we get on iTunes, the more people find us, because iTunes likes you better when people start commenting, and people can find you a little bit better. And that definitely would be appreciated if you can get out there and help us out. We definitely appreciate that. The show is growing, and we want to keep that way, and we like to keep it growing. If you know people that are into electronics and stuff like that, tell them about us. We definitely appreciate any word of mouth. That's the best form of advertising. All right, that's it for this week. Next week, we have LED arrays coming up. So that's what we have for next week. Talk to y'all later. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.